My name is Garrett Roberts, and my subject is the Fundamental Theorem of Calculus. The definite integral plays a huge part in the first fundamental theorem of calculus. The formal definition says, let f of x be a continuous positive function between a and b, and consider the region below the curve y equals f of x above the x-axis and between the vertical lines x equals a and x equals b. Then denote the area of this region by, from the integral from a to b of a function f of x dx, and call this the definite integral of f of x from a to b. All this is, down here on the bottom, is just saying it out easier because none of this formal definition even makes sense. So the easier way just to do it is the integral from a to b, f of x dx is equal to, you have to substitute b and a into the function for x, but you need to do b first because it's always going to be the larger number and it's always going to be on top, and then you subtract a from b, and then that's going to be your whole answer. For example, find the area under the curve y equals x cubed above the x-axis and between x equals 0 and x equals 2. So 0 and 2 are going to be your a and b. They're going to be what you actually plug in. 2 is going to be your b because it's a large number, and then 0 is going to be on the bottom. So as you can see on the graph, it's above the x-axis, and it's from 0 to 2. The solution for it says, use the first fundamental theorem of calculus to get. So as we said, 0 to 2 is going to be the integral part. X cubed is the function, and then dx. To take the integral, all you do is add 1 to the exponent, so 3 plus 1 is 4, and then divide by that number. So x to the fourth over 4, and now this is where you plug in for x using 2 and 0. So 2 to the fourth over 4 comes straight from this, and now it's just algebraic math, minus 0 to the fourth over 4, but 0 to the fourth is 0, so this second part is just going to cancel out, so your answer is just 2 to the fourth over 4. Then you simplify algebraically, so the answer is going to be 4. Notice the notation that was used. This is just a basic example of how to do the fundamental theorem of calculus. As you get higher up in calculus, you're going to get better and better at integrals, and you basically be able to do it in your sleep.